This is the CNC class, and we start with an hour or so in the classroom to learn a little bit about VCarve Pro, and then we will transition into the shop and be hands-on on the CNC. And what we design in the class today, we're going to actually cut on the machine. So you'll be able to see kind of end-to-end as to what's going on. You'll have it, if you desire, you'll have a chance to put hands on the CNC. If you're actually going to be using the machine in the near term, I want you to be hands-on so you understand how to turn it on, how to put bits into the machine, and how to be safely operate the machine. So you'll each have a chance to do that. If you just want to watch, that's perfectly fine as well. We can schedule some other more one-on-one time with you. So there's a variety of tool chains, we call tool chains, to actually get a file that you can actually use on the Forest machine. And it's the same pattern that a lot of our machines operate here today. If you've used the laser, it has the same pattern where you have to design first as step one. Step two is get that design ready for the laser, and then three is to operate the laser. So if you think about the laser, we use Illustrator. Most of the people use Illustrator to design. Getting the machine ready, getting the file ready for the machine is when we go through the print dialogues and that epilogue driver where we're setting those items. That's kind of getting that file ready. Ultimately, when we print from Illustrator, it sends that file automatically to the laser. And then step three of operating the laser, you know how to focus the laser and put your material in and be safe using the machine. CNC has the same three steps. Unfortunately, it's different software. So step one is VCarve Pro for both design, and step two is also VCarve Pro for getting the design ready. We call that toolpathing. There's a variety of tool chains that can be done. Today we're going to talk about the most common and the simplest tool chain, but on the design step, you can do design work in other applications such as Illustrator, AutoCAD. I mean, anything that can create a vector file, you can do that design work. The toolpathing, that particular design software may not have the ability to do toolpathing, so you can't do toolpathing in Illustrator. But the most common pattern or steps are VCarve Pro for design, VCarve Pro for toolpathing, and VCarve Pro will create a file that has to get actually used to operate the CNC. That file is called a G-code file. So it has an extension of .cnc, but inside of it is G-code commands. Another tool chain, which if you want to use this, we can get some other members to help you learn it. But another tool chain is Fusion 360. Design in Fusion 360, toolpath in Fusion 360. Fusion 360 creates the G-code file, and then you load it on the machine and run it. So if you happen to know that application and want to use it, that's an option for you. And as Rachel asked the question, there's a variety of other options on the design side to do vectors, create vector drawings. So today, what I'm going to cover is that basic tool chain of using VCarve Pro. VCarve Pro is, for our members, you can actually install it on a Windows machine. We have a license key that you can use. That license key is in the Slack channel from CNC. It's pinned. We used to have it published on the wiki, and then we realized, oh darn, we're publishing this license key to the world, so we took it off the wiki. And you can follow instructions. It's very easy to install it on your Windows machine. You can do those step 1 and 2. The file that it creates is a .crv extension, so you can put that on a thumb drive and bring it to the Makerspace, put it in the laptop out on the CNC and go from there. And that's what we're going to be doing today. We're designing and toolpathing on this laptop here. We're going to put it on a USB drive and we'll take it out there, so you'll see how that works. The design that we're going to do today and the toolpathing covers some pretty basic things that you would do with any of the work that you're going to do. Generally, people are using the CNC to cut, to actually, in a piece of wood, a 1/2 inch piece of plywood or something, actually cut. We're also removing wood, or what's called pocketing, doing relief of wood, not all the way cutting through the wood, but pocketing. And we're also going to show you how to do some drilling of holes if you want to just drill like a 1/4-inch hole through the wood or even down in. What we're not going to be covering today is using V-bits, where you could actually make some signs. A common use of the CNC is to make different signs, and we'll often use a V-bit, which is relieving wood, taking wood out, but it's not it's concave. And there's different, you have 60-degree bits, 90-degree bits to do that V carving work. There's plenty. We'll probably have another class that shows you how to do that. And there's a couple members here that have done some really nice work using V carving. So today is pretty basic in learning just the profiling toolpath, the pocketing and drilling toolpath. Okay. So if you have a laptop and you want to follow along, you're certainly welcome to do that. The first thing you want to do is create a new file, and you get a dialog that pops up. Generally, we're doing, for this test, we're going to do a single-sided job. Its width is going to be 8 by 8, and it's 1/2 inch. You can control the units here, either inches or millimeters. The scrap wood that I have happens to be 1/2 inch plywood. And from a Z perspective, we're going to set it to the material surface. That's generally the most common thing to do, is set it at the material surface. The other thing you need to think about is, where's your X and Y home? You can change it for design purposes and then change it to a different position as we want to do different operations, or as we actually create the G-code file. Because whatever you do in your design file is where you set the home position, is where you have to set the home position on the CNC. So I'm going to set the home position in the center to design, but when we get out to the machine, we're going to change that home position to be the bottom left corner. There's another member, it's like, well, why would you use a different option? So if you're just cutting something out of a piece of wood, 4 by 8 sheet of plywood or something, you probably will want to do bottom left homing. And it's easier to set the home position there just in operating the machine. There's another member that was working on a project where he was he's making a Chinese checkers board. So he had taken some wood, I think he had used walnut, and he had put it together to make this 16 by 16 board, and he cut it to size. He didn't want to use the CNC to cut it to size. He just wanted to actually use a V-bit and create holes, pockets for the marbles to sit in. So in that case, when he did his design work, he wanted to use center for XY home. And then before he actually operated the machine, he just drew diagonals on that piece of wood and got to the center of that wood, and that's where he set his home position. But you have to be consistent. When we take our design out to the CNC, when we create that G-code file, wherever the home position is, that's what the machine is going to think we did. That's what it's going to do. So you don't want to design and create the G-code file with the center homing and then go out to the machine and set your home position to the bottom left. You will not get the intended behavior. VCarve Pro is the version that we have with the license key is fully functional with one exception. The version that you run on your machine cannot create that G-code file. You can do everything else. You can do all your design work and tool pathing. It just will not create a G-code file. That's how it's crippled. And that's why you have to bring your file to the laptop at the CNC. That is the only machine that's licensed to be able to create the G-code file. Okay. So 8 by 8, 1/2 inch, center homing. This, you'll see some stuff about material setup. This has nothing to do with what the actual material you're working with. This is just for purposes of the rendering capability inside the machine. So I'm going to click OK. We now have our starting piece, and I'm going to click Save, and we're going to call it CNC Class 5. So we're going to do all the design work first, then we'll do tool pathing. As you end up using the program, you can decide to mix and match. Over here on the left-hand navigation, you have some different icons for different functions. There's a whole set of icons here to create different vectors. There's a way to transform those vectors if you want to rotate. We'll use some of those today. And then the ability to do some editing or measuring. So the first thing we're going to do is we're going to draw a circle, and we're going to have the center point be 0, 0. That's wherever my home position was, so it's going to be in the middle. And whether you want it radius or diameter, I'm going to set it to diameter, and we're going to set it to 8 inches. Sorry, 7.5. So we get this nice big circle that's there. And that's the only one that I want, so I'm going to click on close. The other thing that we're going to do is, in order to show the drilling operation, we're going to create another circle. For right now, I'm going to set it to 0, 0, but the diameter is going to be 0.25. We're going to be using a 1/4 inch end mill, and so we're going to just drill a 1/4 inch hole there. And I put that in the middle, and I'm going to click close. So I now have 2 vectors here. When you single click on a vector, you notice how it changes color and it's a dashed line. You can move that up and down as you would like. If you happen to double click it, you end up with some extra handles that allow you to do some resizing and moving. So it's single click or double click. I'm going to single click that guy, and I'm just going to manually move it up to the top because I want this hole to be drilled up here. Pretty typical Windows application where you can do shift and click to select multiple objects or vectors, and we will be doing that as we do one of the toolpath operations today. The next thing we're going to do is we're going to be putting the MakerFX kind of a hexagon in the middle with the letter M here. So we're going to use this vector to draw a polygon, and we're going to have it be 6 sides. We're going to set it at the center point, and the radius, I think we ended up with there we go, 3.3. But it's not in the right position to match the MakerFX logo. So we're going to select that vector, and we are going to transform it. So if you hover over these, you can see different operations. You can move, you can change its size, you can rotate it, you can also mirror. So I'm going to click on the rotate option, and we're going to rotate it 90 degrees. Okay. And that's all we want to do is get that to look more like the MakerFX hexagon. And I'm just going to click anywhere on the surface to deselect that vector. And the last item I'm going to draw on here is we need a letter M, something close that we can use. It's not going to match perfectly, so if you're a creative type and you're like, hey, that M doesn't exactly match the M on the MakerFX, my apologies. You'll have to go with the flow here today. We're going to do the letter M, and the one that I found that's close is a true type. I think it's Verdana. There it is, Verdana. And the text height, was it 5? No, it was 4. We'll do some, I'm trying to think what, trying to remember. It ended up being a little bit smaller. It ended up being 3.5. And I'm just going to manually move it so that the M, that point is right there in the center. And we're going to save our work. And so we may come back and edit some of this. We'll see. The nice thing about VCarve Pro is that we can visualize what the finished product is going to be. And so as we do the tool pathing, if it doesn't work out exactly as we'd like, we can come back and make some changes to it. So that's the end of kind of the design phase. Pretty basic. We got 4 vectors up on here, and we're going to end up creating 4 different tool paths. So on the right hand side, there's a option here. If you fly out, when you fly it out, there's there's a little pin there that you can pin to keep that automatically open, and it'll be easier if you do that. And over on the right hand side are the different toolpath operations. So this is where we're going to do profile, pocket, and drilling. What you want to do is select the one or more vectors. So we're going to select the outside profile, and we're going to the outside vector. We're going to click on profile, and now we get a whole bunch of options. This can be a little bit of intimidating at first, but in the end, you'll get the hang of it. Normally, when you start this, you'll have this little tab over here that says Toolpaths, and if you hover over it, it'll fly out. Once it flies out, there's a push pin there. You can press the push pin, and you can keep it open. And it's easier to keep that guy open while you're doing this. And so then select one or more vectors, and underneath the toolpath operations, there's a whole series of icons that are in here. We're going to select that profile toolpath, because that's the first thing we're going to do. Now, there is an order of operation of the toolpaths that you need to think about before you actually create the G-code file. But for purposes of just the initial toolpathing, we're going to do it in the wrong order, so that you can, because the profiling is a little bit easier to learn and understand that one first, but then later on we're going to change the order of the toolpathing, what we actually want the machine to do. So if you're in this particular case, we want that particular toolpath to be last, because it's kind of the last thing that would ultimately cut out from the piece of wood, but we're going to design it first. So select that outside circle and then click on the profile toolpath. So there's a lot of options that are here, and we're going to go through most of them. So the start depth, and they give you a little visual here, but in this particular case, we want to start at the top of the wood, so it's 0, and we want our cut depth to actually go through the piece of wood. So if you remember, we're working with 0.5 material, so a common thing to do is to say 0.51. Now that piece of plywood, if we were to measure it, it's not perfectly 0.5 anyway. So we're going to clearly, even if we set it to 0.50, we're likely going to go through it. But generally, this is very common. If you set it to be 0.5, you can set it to be 0.51. If you want to be precise in the material you have, you can measure your material and change it. When you set up the job type, that's perfect. That's up to you. But what you're going to see on the machine is we have a spoil board. There's a piece of plywood or MDF that's there for us to go all the way through and cut through. So this is not necessarily an exercise, and it has to be in precision. The next thing we want to edit set in our toolpath is the tool. The path is the vector, one or more vectors that it's going to follow, but now we're going to tell it which tool. And it remembers the last tool that you used when you did your design work. And you can click on, so it says an end mill, a 1/4 inch end mill, which is what we're going to use. So we're going to click on edit so you can see the different parameters that are here. So it's a 1/4 inch diameter. It has 2 flutes. That's what we're going to be using. And you have some cutting parameters, for each pass that it goes, how deep do you want it to go? And then the next section is called feeds and speeds. And this is an area that ends up being a bit of an experiment. You have trial and error with the piece of wood that you're using or the material. There are some well-known feeds and speeds that work with a particular type of wood. But generally, from an RPM perspective, we can start down around 12,000 RPMs if we're cutting through plywood. The feed rate is the speed at which you want the actual router bit to move along that path. 40 is pretty slow for plywood, but you may find if you're cutting oak or other kind of hardwoods that may be a more appropriate speed. You may even have to go lower depending on the hardness of the material you're using. For today, we're going to go ahead and we're going to use 90. And then plunge rate is the speed at which the router bit's going to go into the material. And it does that when it needs to cut initially, it needs to go down before it starts moving. And what you'll see, we're going to be making multiple passes to go through this 1/2 inch material. So it goes down initially, follows a path and cuts, and then goes down again and follows a path. And so that feed rate that's what we're setting here, is how fast it goes down into the wood. So you normally see a pretty slow speed here of like 10. That's also the speed when it does drilling. Later on you'll see when it's drilling how fast it goes into the material is a function of that setting. One thing we need to do on the wiki is create a nice little page that details when people have experience using something, what was the settings that they used, so that and there's plenty of sources on the internet for how to find feeds and speeds. It's a function of the material you're using and the router bit, the quality of the bit that you're using. And oftentimes it's you start with do a little bit of trial and error if you're not doing something that's well known. We're going to come back and talk later, and when we do another toolpath, we'll talk a little bit about these other parameters, about step over. We do need to talk right now about the pass depth. So right now it's set to 0.1. I'm going to leave it there for right now, and let's click OK. And notice in this dialog box it says it's going to make 5 passes. Does that make sense to you? There's kits that are on Amazon you can buy for different bits. The shapes and stuff, right? So a lot of what's are in those kits are V bits. You may also have like a 1/4 inch end mill, an 1/8 inch end mill, and some different size V carving bits, whether 90 degree, 60 degree. I have a collection of bits that I brought with me today that when we get out in the shop, that we'll actually see, because you'll have an opportunity you'll see me put the bit in the machine, but then I want you to also have the opportunity to use the tool and put that in the machine and understand how that works. Most of what's different is with the V bits is there's a difference between you get a different outcome with a 90 degree versus 60 or a 15. So you can also, we did edit here, and you notice how it did 5 passes, and that made sense, right? The pass depth was 0.1, so it's going to make 5 passes. This is a function for you to think about the material you're using. In the case of plywood, we don't need to we don't need to do 5 passes. We could just do 1 pass if we wanted to, because plywood is that forgiving. But for purposes of the test today, I want to show you that we're going to do 2 passes. So we're going to come in and we're going to change that pass depth to 0.25. And it changed it to 2. And if you go, well, wait a minute, shouldn't the last pass be like 0.01? Well, the machine is smart enough to say, I'm not going to do that. And so it actually, you can see what the 2 passes are going to be. Okay. Then you have to decide how you want the tool to follow that vector. Do you want to follow it cut on the outside? Do you want it to cut on the inside? Or do you want to follow exactly on the line? It all depends on what it is that you're trying to do. In this case, we're cutting it out, and we want that circle to be as close to 8 inches as possible. So we're going to set it to outside. What's the difference between climb versus conventional? It has to do, when you think about wood, it's going to be whether it's going against the grain or with the grain. So notice what happens to the path. And this is what's nice about VCarve Pro. Some of the settings, it gives you a visual clue so you can see what it's doing. So in this case, climb, it's going counterclockwise. If you do conventional, it's going to go clockwise. So it's something for you to think about relative to the material you have and following the grain in the case of wood. But we're at some point in cutting this, if we were cutting it on oak, at some point it's going to be going with the grain and against the grain and cross grain. There's really, so you may find that the piece of material you're using has a different quality with a different setting of this. We're going to come back and do tabs. We'll do this in 2 paths, and we're not going to use any of these settings here for today. When you scroll down to the bottom, it has a way to name this. So we're going to call this the outside profile. And we're going to click on calculate. Now this is going to be a common warning that you get from the application that says, hey dummy, you told me your material was 0.5, but you asked me to cut 0.51. Is that really what you want to do? And for this particular toolpath, yes, that is what I want to do. What you want to be careful of is that you may get too used to just saying okay, and that may not be the intended outcome that you want for a given toolpath. So that's a very common dialogue that shows up. So as soon as you do this, you end up in the preview mode, and notice how we have a 2D and a 3D tab that's up here. We're going to be using this section, and we're going to preview the selected toolpath. I want you to if you're following along, take your mouse pointer and move this speed way down. In the early parts of using VCarve Pro, you'll do this because you'll go, oh, this is really cool. I can see how the machine's going to work. Later on, as you become more comfortable with it, you're just going to move that all the way up to the end so that it does it really quick and you can see the finished product. But at the beginning, it's really cool to see the machine kind of operate. So move it, slow it down, and click on speed, and you're like, oh, that's cool. Look at that. I can see the router bit doing its work. So this is making pass 1. And talking about climb versus conventional, so you can see that it's going, you would see a different, it didn't go in the same direction, did it? The climb, it said climb was going to do. If you had 2 circles and you needed to do the same thing, you wanted to profile, do you need to create 2 different toolpaths? The answer is no. You can have a single toolpath that selects multiple vectors, and it will do the same thing for both of those vectors. So when this is completed now, we can see that this is you can hold and drag, and so you can see things 3-dimensionally, and you can see that's what we would expect out of this. Right? So let's click on close. We now have this single toolpath that's here. I'm going to go ahead and save our work. In order to get back to our design, we go back over into 2D mode. But I want to go back into that toolpath and make some changes. There's a couple ways you can do that. You can double click on the toolpath name to open it up. You can also right click and say edit. So we're going to go down to we're going to now add some tabs. There's a lot of debate about whether you need tabs or not. Plywood is very forgiving, especially 1/2-inch plywood. Even if we were to cut that out, that piece isn't going to move significantly to worry about it. But some people want to have tabs left. And so we're going to take a look and show you how tabs work. We're going to click on Add Tabs, and we're going to go to the Edit Tabs option. And it's going to ask us, we're going to use the, we want a constant distance between tabs, and initially I'm going to change this to 3 inches. And I want a minimum of 2, a maximum of 10, and we're going to click on Add Tabs. So if you ever see on a vector this box that's yellow and has a T, that's a tab. And we're going to go ahead and that's how it placed them. So it automatically placed them on that circuit, on that vector. The purpose for a tab is that it's going to be an area that it doesn't cut all the way through the wood. And so that whatever we're cutting will stay intact, and we can then take a saw or something and actually cut through the tabs and then finish it up. It's a way to keep something that you're wanting to cut out permanent, placed and positioned, so it doesn't move or just doesn't come out. With plywood, well, a lot of what we do on plywood, we don't use tabs, but there may be other situations where you want to use a tab, so I want you to see how that works. And we're going to click on close. Let's go ahead and just have these, how many did it do there? 8 tabs. And we're going to come down and we're going to do calculate. And when you get back into the 3D view mode, it still showed that it was rendered. So you're going to use this option to reset the preview. And I'm going to speed this up just a little bit. And we're going to click on, we're going to play this guy. Now, once it's rendering, you can't change the orientation. But the first pass is the same. but this second pass, you're going to see it not cut through the wood. 1, 2, 3, 4, 5, 6, 7, 8. So those are the tabs that you can see that it left on the outside of that. If we go back into the toolpath, you can control the thickness. So this was a leftover from the last time I did it. So the thickness of those are going to be 1/8 inch. So it's a 1/2 inch material. We told it to go down. The cutting depth was 0.25, so it's going to do that. And then that second pass is where it's going to leave that to be an 1/8 inch tab. So that's how you get back in and edit a toolpath. And sometimes you'll do that. You'll experiment with some different things, but you always want to click on calculate. The most common types of end mills that we're going to use are, both of them will have a 1/4 inch shank. Those are the most common, but the actual cutting end of that will either be also a 1/4 inch or an 1/8 inch. But they make different sizes of shanks, but those are the two most common ones that you can use. Which one you use is really a function of what you're ultimately trying to accomplish. The most common one that we end up using is a 1/4 inch shank and a 1/4 inch cutting. If you ever get back to the 2D view and you have all these errors and you're like, what the hell, where did they show up? There's an icon that's up here that says toggle toolpath 2D drawing visibility. So you can turn that off, okay? So that was toolpath number 1. We're going to do the pocket toolpath next. So what we want to do is, it's a little bit hard to see, but where my mouse is going here, this area, we wanted to actually remove a 1/4 inch. We're not going to go all the way through. It's 1/2 inch material. We're going to remove a 1/4 inch of that material. So in this case, we're going to select 2 vectors. So we're going to select the outside vector, and I'm going to select that inside vector of the hexagon. So I've got 2 vectors selected, and we're going to do a pocket. So a pocket toolpath is you're removing material from inside of something. So you can just select 1 vector and do a pocket, but it would remove all of the inside of here, and that's not what I want. I want to remove the material from between that vector and that vector. So you can select multiple vectors to do a pocket. That pocketing toolpath, you can use it for different things. So sometimes you just select a single vector and you want to pocket that. You can also select 2 vectors and have it pocket between them. In this case, we're doing that. Select 2 vectors and pocket in between. So it's the same thing here. You've got what's your start depth, what's your cutting depth. In this case, we're going to say 0.25, right? We don't want it to go through all the material. And we have to select our tool. And the settings for the tool on this toolpath can be different than the settings for what appears to be the same tool on a different toolpath, right? So you can truly customize what you want the machine and the tool to do for a given toolpath. So we're gonna leave it at 12,000. We're gonna still go at 90 inches per minute, and the pass depth we're gonna set it to 0.25, which is what we had before. But now we need to think about what's called step over. And probably the easiest way to think about step over is we have a tool that's out there that's 1.5 inches in diameter. And so when we use it to surface material. So when you're doing surfacing, it's really a pocketing toolpath. But if you want to think about that 1.5 inches, the first time it goes through a piece of material, it's probably taking 1.5 inches of material. So you go 1.5 inches one way. But we're surfacing. So now we need that tool to move over and come back. And do that consistently. When it gets to this side, it moves over and goes back, right? So that jog to move over before it comes back, that's called step over. So how far do you want that tool to move over before you come back? And that's going to influence how much material you're asking that tool to cut out of your material. So in the case of like that 1.5 inch fly cutter surfacing bit, it depends on the hardness of the wood that you're dealing with. I was helping a member a couple months ago when we were surfacing these big slabs of oak wood. And oak is generally known to be hard. And so we started with really small step overs. And then we realized, well, it's been drying for 2 years and it's not that hard any longer. And we were able to set the step over to 1 inch. So, and we were making these 1-inch passes across this big thing to surface it. So that hopefully that made sense to you when you're thinking about something that's 1.5 inches and how much you want it to move over. The same thing applies for still this little 1/4 inch bit. How much do you want it to move over?
It's going to overlap then.
It's going to overlap, right? So you might be tempted to say, well, let me set my step over to 0.25. You could do that. What you'll end up with are these little, very thin slices that the bit doesn't get just because of the accuracy of the machine. So generally, you'll see a step over, like today, let's use a step over to start of 0.1. And then we'll come back and we'll edit this. Again, it's a function of your material and how fast you want to move that can influence what that step over is. You can also just set a percentage as well. So, and the program will automatically compute that. So you could set that to 80%. But right now, let's set it to 40% so you can see how this works. So 12,000 speed, 90 feed rate, and we're going to click OK. And then we get into another setting here. So it's going to do 1 pass, which is what we expected. We told it to go down, the cut depth is 0.25. What do we want the offset to be? Do we want it to be, or how do we want it to do its work? The option is offset or raster. So raster goes back and forth. Offset is doing a circular pattern. And then you also have climb and conventional that controls the direction. Let's start with offset for a minute, and so you can see how that works. And we're just going to change this to pocket. And we're going to click calculate. Now, we get into the 3D viewer. I'm going to reset this, and we're going to move the speed up a little bit. And we're going to, this time, the question is, which one do you want to view? If you say preview the selected toolpath, it all depends on which one you have selected, but the one that we just created is what's selected. And this is now a visualization of the pocketing operation that it's going to do. And if it may have gone a little fast, so we can, if we slow it down. What I want you to kind of just visualize, see how many, the blue lines, those are the different paths that it computed that it needs to follow to do the work that we asked it to do, the toolpath to do. And I didn't reset it, so the visual is still there. So that's where you're doing the speed again, but you don't see the tool operating. That's because you didn't reset it. So if you reset the preview, it wipes everything clean, like an Etch-a-Sketch. So you can see how many movements it has when that step over is just at 40%. We're going to come back in a minute. We're going to change that step over to be 0.25, sorry, 0.2, 80%. And you'll see it'll be a smaller number of movements to actually remove the material from between those two vectors. Right. I'm going to click on close. I'm going to double click on pocket, and I'm going to edit my tool, and I'm going to set this to 80%. You can see there's a smaller number of blue lines now, right? And so we should, as it does its work, you can see that it'll do that pocketing operation much quicker and still with the same output. If I were to set it to 0.25, visually we'd be able to see that it removed everything, but in practice you're going to end up with these little slivers that end up there, which is not what you want. Can you see the estimated time? You can see it here. You can also see it on the machine. I think when you're back at this view where you're creating toolpaths, there's an option here that says summary of all toolpaths, including estimated times. This icon, it's on the bottom row, second from the left. And I selected both of those, and it estimated the machining time to be 4 minutes. Okay, so we'll have a good test. Remind me to, once we get all the toolpaths here, we'll see what VCarve thinks it is, and then we'll see what the machine says or estimates, and we can time it and see how accurate they are. So that's 2 of our 4 toolpaths. We're going to actually pocket, we're effectively going to pocket out the M, but we're going to go all the way through the material. So we could do a profile and do it that way. You could also do a pocket. It's your choice as to which one of those toolpaths you want to use. But let's do a profile. We're going to select the M, and we're going to do a profile. Again, it remembers the last setting. So in this case, it has that we want it to go through the material, and we can leave it this way and let it do 2 passes. This time we want to do an inside cut though. We want to cut on the inside of that M. Now, this M has nice square corners. We're using a round bit, so we're not going to have nice square corners of the M, but it's going to accomplish what we want. And we're going to profile, inside profile M. What am I call that one? You can call these toolpath names whatever's meaningful for you as you're doing your design work. We're going to click on calculate, and we're going to reset the preview, and we're going to just let it see it profile out the M. Okay. How do you delete a toolpath if you just want to start over? You can if you double click on it and get into the toolpath settings, there's not a delete option that's here. So you would have to first close, and then back at this view, right click and click on delete. And you can say delete this, you can delete all. Be careful with the delete, depending on what you want to do, but that's how you would delete a particular toolpath. And then the last one that we're doing is the drilling toolpath. So we're going to select that top small circle, and I'm going to select on drilling toolpath. You're kind of seeing the pattern here, right? Where do you want to start, and what do you want? How far do you want it to go down? So we want to go all the way through this, and we're going to select a different tool here. I don't know what it was doing there. So this is a little different operation. Instead of using the tool that it previously had selected, we're going to select something out of the setup here. There is a way to go. There's an option you'll see in here about getting, I think it's online. You can log in to enable a tool database. But you may want to do that on your, I think you have to have, I think what I learned on this one is you have to have a licensed version of the software as opposed to just having a logged in account. So, but it comes with some standard bits, and you can change and edit them for the bits that you're using. So we're going to still use this 1/4 inch bit, and we're going to set that depth to 0.1. Step over, it's not going to apply. 12,000. Feed rate doesn't apply, but we'll be consistent and set it to 90, and our plunge rate is 10. And we're going to select that tool. So pecking is something you want to think about as well when you're drilling. If you think about it, if you were manually drilling something, oftentimes, especially if it's 1/2 inch, you usually just don't take a hand drill and a bit and just, right? You don't do that personally yourself, and so you don't want the machine to do that either. you'll want, what do you do when you drill a bit through that? Which you'll drill a little ways and pull it out, let some relief of that wood come out, and then drill it through again. That's called pecking. And that's, you can ask the machine to do pecking as well. So we're going to turn on peck drilling. You don't see it visually here on the rendering software, but if you pay close attention when the actual machine is operating, you'll see it, how it does its pecking. This is very important if you're drilling through MDF. MDF is, even if you were manually drilling it, you have to go do pecking, and you'll have to do that yourself. If you don't do pecking, on certain woods, you will create a fire. It's like an MDF. If you try to drill MDF without pecking, you run the risk of creating a fire. I speak from personal experience. I was in order to place the MDF that represents the spoil board today, I needed to drill some 1/4-inch holes so I could get some bolts to go through into the T-track. So I had measured, and I went over, and this was 3/4-inch MDF. I didn't do pecking, and I just wanted it to drill. And it started, and all of a sudden it started to smoke. I mean, there was smoke coming out of this, and I hit the E-stop of the machine. I'm like just scratching my head, and I checked with another member and said, what am I doing wrong? Well, what are you trying to do? And he said, no, you have to use peck drilling. MDF is, it's I don't know how the hell they make it, but when you drill it, it just kind of turns into this thing that looks like a cotton ball. And you now have this drill bit that's spinning at 12,000 or 16,000 RPMs. If you don't let that material evacuate, you're just creating a fire. So MDF, you still have to be, on profiling on MDF, that's fine. You still have to be careful. It depends on if we're profiling on an outside, you're fine. Some of the other holes that you'll see, we have dog holes out on the spoil board. Those are about 3/4 inches in diameter. I did inside profiling on them, and I also had to be careful in my cut depth because of, you have to let that material evacuate and get out of the way, but definitely with drilling, because you've got this bit that's running 12,000 RPM in that material, and if it doesn't have a way to leave and get out of the way, it'll just sit there and turn into a fire. So be very careful with MDF. So I want to show you pecking so that you can see it. Again, we won't see it on the 3D rendering on the software. When we operate the machine, we're going to keep the dust shoes off. At least there's 4 different dust shoes. We're going to keep one of them off so you can actually look and get an idea of what it's doing. But just visually, you'll be able to see the machine peck. In this case, I want to select this option to say retract above the height of the cutting start depth. I want that bit to come all the way above, and you can also even set a retract gap. So I want to say 0.25. I want it to come not just up to the surface, but I want it to come all the way above the surface to allow that material to evacuate. And the peck depth, it automatically set at 0.1. That was a setting that's on the tool as to what its cut depth is. Give it a name of drill and click on calculate. And it's going to complain because it says you're going all the way through, and we go, yep, that's what I wanted you to do. In this case, when it's really hard, I don't think you can see it even slow. Yeah, you're just going down. So it's not the drilling operation is not something that you can easily see. So let's do this. Let's select all the toolpaths now. Now, if you go, hey, how do I get back into the renderer? If I go back over into 3D, you can see that, but I still can't get to those radio controls. There may be something that I'm missing, but what we do is you double click on any one of the toolpaths and just click on calculate. And then it gets you into the preview toolpath menu. And let's reset, and let's rotate this so that you can see this. And then we'll ramp the speed up a little bit and click play. And so when I do that, it selected the selected toolpath. What I needed to do was preview all toolpaths. I guess it does, I guess the answer is, Rachel, you can see it. It's just while it's running, you can't change the angle. The primary thing is that what I was wanting it to do? So let's do this just to kind of illustrate this. So let me show you how to edit. One thing we didn't talk about is editing an object. So let's say we wanted to change the size of the hexagon. So I'm going to select that vector, and I'm going to go over and say, use this second icon under transform that says set the object size. And I now get back into the similar dialog where I was at before. But let's change this up a little bit. Let's make this 6. And that's probably pretty good. Just trying to illustrate, have something to show you illustrate what the issue might be. So now that I've changed the size of that, I still need to recalculate that toolpath, right? And that was the pocketing operation that I wanted it to do. So I'm going to right click and say recalculate. I'm just going to recalculate that one. That's one way to recalculate. But you can also go back into the toolpath because I want to get to the visualization. Click calculate. Reset the preview. I'm going to turn this back so we can see it and zoom in a little bit. And then preview that toolpath. Whatever the last recalculate you did is what's going to be used to create the G-code file. Okay, and we can't create G-code file here. We can only create it on the laptop. So when we take the design file out to the machine, that's one of the things we're going to do there is recalculate there. Just one last time before we actually create the G-code file. Sometimes with pocketing operations, the spacing that you have and the size of the bit doesn't get you the outcome that you're looking for. So that's one benefit of doing the visualizer. I think when you get into VBit as well, Ron, and some of the stuff, you'll be able to better see how some of the VBit work is doing. So that I showed you about how to edit an object, right? You can just select the vector and you can click on change its size. Let's go ahead and let's say you wanted to change the size of your material. This icon here for set job dimensions and origin will take you back to this dialog. I'm going to do this now. I'm going to change its home position down to the bottom left corner because there's something I want to show you. Yep, I know all that. So sometimes you want to have some guidelines on your design to help you with placement of things. So when you can right click and there's an option that says guidelines, and you can either insert a horizontal or vertical guideline. So I'm going to go ahead and insert a horizontal guideline and put it there. I can move it down if I want, manually move it to where I want it to be. And if you notice the visual there, it gives me an idea of where it's placed. I can also just right click on it and set its position. So I want it to be 0.25 from the bottom edge. So just automatically put it there. And then I can also guideline and create a vertical guideline. Right click and set it to be 0.25 and apply. And now I have two guidelines vertical that are 0.25 from the edge. If you right click and you want to create a new guideline, it can either be an absolute position or relative to the current guide that I have. And I want to create 1 inch guidelines that are 1 inches apart. And I want to create, I don't know, 4 of them. Create new guides. So you can get, if you need something on your design to help you with placement, you can put these guidelines up. You can't toolpath them. It doesn't, it's not gonna, the machine's not gonna do anything with them. It's just a visual aid, just for design work, yeah. A couple other tools, things that, there's a ruler that's in here. So under edit objects, there's a ruler. You highlight it. And so while this is open, then you're gonna come over to your actual design. And let's say we wanted to know what the distance between that point. So you click on one point and you start pulling out kind of a tape measure. And then as it intersects different vectors, you'll see it stop. And you can click a second time if you want. And that way you can see what the distance is. So that's almost, almost 1 inch between them. So it's a handy guy called the measuring tape. So there's a lot of other capabilities inside of it. It's a pretty powerful design program, depending on what you're trying to accomplish. It probably will work, but if you know Illustrator, you're more comfortable in Illustrator or something else, you can also do that as well. So I think, unless you have any questions, I think we'll...
Can you upload images to it?
So you can, images would be, that would be a kind of would get you to some other videos to see how people are doing things with pictures. But you can, under the file import option is where you can import vectors, import bitmaps. So like if the question, if you had drawn stuff in Illustrator and saved it as a .svg file, you would do file, you'd set up the size of your job, and then you would do file import the vectors, and you would go find that different file type. And these are the different types that it can import. It can import quite a few different types. So it could even create a .ai file. This is really just the basics to understand how to do a design work, do the toolpathing. We've talked about 3 different types of toolpaths. Profiling, which is cutting generally, pocketing, removing material in an area, and drilling. Those are the most common things that people use. At the beginning, I told you we were doing it out of order. And when you're here on the toolpath view, once you select a particular toolpath, you end up with you see these arrows up or down. And so in this case, I want to move the outside profile. That's the last thing that I wanted to do. Let's go ahead and make the drill the first thing so you can see it. And we will then pocket, and then we'll do the inside of the M, and then we'll do the outside. Now, we have the tabs on, so it really doesn't matter. But if I wasn't using tabs, this would definitely be the order of operation that you'd want to do, because if outside profile went first, we now have a disk that's going to shuffle around and come out at us, actually, is what it'll end up doing as soon as we started that pocketing operation. So, and I'm going to right click and say recalculate all, just to let it do all of that. So before we actually start working on the machine, we're going to talk about bits. There they come in all shapes and sizes. The most common bit that you're going to use is going to be a 1/4 inch shank, and then two flutes at the end. So there's 2 cutting surfaces we'll go through. This is what one of them looks like. They actually go into the machine and do what's called a collet. And the collet has to match the size of the shank. So we have 1/8 inch collet, 1/4 and 1/2. Those are the most common sizes. So think about that when you're buying bits. You probably want to buy, most of what you're going to buy are going to be 1/4 inch shanks. So it actually fits in the shank like that. It'll go in, and this collet itself actually gets placed in this nut. So the order of operation is, normally what's in the machine is the 1/4 inch shank, the 1/4 inch collet pushed into this nut. And it just pushes in. You'll hear it snap. And to get it out, you just push that guy out. There's a plastic container that's underneath the machine. We have 2 nuts, and then there's 3 different collets. So it's pretty easy to actually push the collet in. And then the bit will go in, and it'll hold it there to the point so you can actually insert it in the machine. What we'll actually do, this will be on the bottom of the spindle already, kind of hand tightened, and then we will push the bit up and then tighten the nuts. And there's 2 wrenches that we'll end up using to actually tighten the nut, and that causes the collet to clamp down on the shank and hold the bit in place. Everybody will get it, if you want to, you'll have a chance today to actually mount that bit in the machine. So this is well documented on the wiki. If you go into the CNC remember I told you about the different steps? Well, we've got a 4th step here that talks about finishing for this particular tool, but underneath step 3 for machining, there's a section that says CNC operations. I do not have anything documented for changing bits, but we now have a nice video of that. So we're gonna go to startup. So turn it with the laptop's already turned on, so you turn that on first. Press the green button on the controller. So kind of press and hold, and it will start up. And then step 3 is to launch the router control application. It is down in it's pinned down here, so you can actually click that and it'll start up, and it'll say establishing communications with Acorn. Acorn is the control board and software that's inside of that box. And it actually started 2 applications. It started an extra application here that's this C that's down in the, which is what they call the virtual jog. I call it the blue application and the green application. The green application is what we're going to use to kind of move the machine, start and stop the machine, move it. And the blue application will be where we're going to do some configuration, setting the X, Y, and Z home position, loading our job, and actually initiating that we want to start running a job. But as you toggle back and forth between like Chrome and go to this application, the jog application doesn't show up. So you may just have to go down and select it itself to get back to it, okay? So this is, you just follow along. It talks about the 2 applications. The first thing to do is to verify that the gantry is in the home position. So the gantry is down here that holds the spindle, and this is the home position. So that's the last thing that we do is we initiate a part command that will actually park the machine in that position. If you were to happen to find somebody didn't do that, you would have to first manually jog the machine back to close to that location. You would have it powered up, and you would use the green application to actually move it. Okay, so don't ever manually try to move the gantry. Yep. So in the wiki, it said that step 5 is to actually reset this button. You'll see it here, that you have to press that in order to reset that. And this button also serves as the e-stop when we're running a job. So you can do it virtually here, or you can actually physically press that button. This screen is a touch screen as well, so be careful. If you're touching around, you may accidentally press the e-stop and you really don't want that actually to happen. The first step is to press reset home, and if you may be confused about what's X, Y, and Z, just look at this. So Y, just as you operate the machine. The Y is this direction, X is across, and Z is up and down. Did you hear that click? Those are the end stops. So there are physical end stops that for both of the dimensions. And so what I'm doing is I'm moving them off of those end stops, so then I can click on reset home. And it will now, the machine's running through a job that is going to move. It starts with Z. You hear that click? So that's where it moved it up and hit Z. And it's now doing the same thing for the X-axis. You can see the spindle starting to move over, and it's going to hit the end stop. And there are 2 end stops on the side of the gantry. And so it's going to be this is going to take the longest part of this is moving that X end. So it's moving it very slowly. You can see one of the end stops that's over there on the right. So this is important because this is the machine's home position. If you forget this step, if you don't do this, you'll do all the other steps and you won't be able to run your job. I can speak personal experience that has happened to me. Generally, you only make that mistake once or twice, and then you remember to do this first step. But there's the machine home position, and then the other is going to be our job home, wherever we mount our material and actually ask it to run the job. And what we're going to do today is we're not going to put any wood up just yet on the first pass. I'm going to show you how to, I'm going to set the job home kind of artificially high, and we're going to run a job it's a 20-minute job that we use to cut on a 4x8 sheet of plywood. So it's just going to be, we're going to go ahead and put the router bit in so you can see how to do that, but then we're going to run this job so that you can see the machine operate and you can kind of get comfortable how you might stop it and start operating the application. And then after we complete all of that, then we'll actually mount a scrap piece of wood and cut out our design, okay? So at that point in time, it's completed its things, and down in the machine coordinates are all zeros. So that's what you see as the last step in the wiki. So we're going to go on to the next step. And what we're going to do is, this is the first part of this, we're going to jog the machine up so that we can mount, put our bit in. This button here in the middle is important. It has two symbols on it. One's a turtle and one is a rabbit. And there's a light at the top of the top left-hand corner. When that light is on, it's the top side of that button that's active. So in this case, it's in turtle mode. So if I'm pressing and holding X plus, you can see the gantry is moving really slow. If I turn that light off, that moves much faster. So for purposes of getting it to jog up here so we can put the bit in, we're going to keep it in rabbit mode or fast mode and get it up here. When you're setting your home position for your job, as you get close to that home position, you'll want to turn it back to turtle mode, slow movements, so you can be a little bit more precise in setting that position. So all I'm doing is pressing and holding. It's very responsive. As soon as I let go, it stops. At this end, there are physical end stops, one here and one there. So you will not be able to run this thing off of but I want you to hear what happens. Okay. So we're going to reset home position, but if for some reason you hear it that you've hit the physical end stops, please try to avoid doing that intentionally.
You probably lose the home out there, right?
We've now lost the home position by what I just did, yes. But we're likely going to lose the home position anyway as you learn to put that nut on. Some people can be really strong and will cause the gantry to move. So the dust shoes, there are 4 of them. There are 2 screws that you have to just loosen for them to come down. You don't ever have to worry about removing the back shoe, but you'll likely want to remove the 3 dust shoes as you do this. We talked about the nut and the collets. I'm going to go ahead and I'm going to hold the spindle itself with one hand and spin this on and just move it so that it's I just kind of the nuts hand tightened, so I can I can actually get that bit pushed up in there, and if not, you kind of push it up and tighten it a little bit so that it does stay. Now, people ask, how far out of the collet does the bit need to be? I'm going to go ahead and take this nut off, I guess, and do this again. So you want to think about, so you should not push it all the way up, right? That's not correct. At a minimum, you want to you want to have your cutting edges to be out. So that would be kind of a normal position. But you also want to think about what you're doing, what the job that you're going to run. I can speak for this firsthand. These dog holes, there's 2 pieces of 3/4 inch plywood, or MDF. I needed to go all the way through them, an inch and a half. I created a job and told it I wanted to go through an inch and a half. And the machine is doing the first hole, and all of a sudden the machine starts shaking and starts smoking. And I hit the E-stop, and I'm like, what in the hell happened? Well, what had happened is this nut was setting right there, spinning at 12,000 RPMs. And thinking it was, because it was doing exactly what I told it. And it was wanting to continue to go down through the machine. It causing the machine to shake and smoke. So now that's an extreme example, but it illustrates the point that you want to think about how much bit you have out. In my case, I only had an inch worth of bit out, and it didn't have enough room. I had to, once I realized what had happened, I had to adjust the settings so that I had more than an inch and a half of bit out to be able to go all the way through both of those pieces of MDF. Most of what that's a very uncommon thing that you likely wouldn't do that. But don't put it all the way in, don't have it all the way out. Generally, that's probably a good setting like that. That'll have plenty of bit for you to do your work. Two tools. This tool holds the shaft of the spindle. This goes on the nut. Everybody's going to have a chance to do this. You want to bring this tool up from the bottom. It doesn't go on this way. That's not the right way to do it. You want to make sure that all 4 points are actually on the nut. And then it's opposite of what you normally would do. It's righty, it's not righty tighty, lefty loosey. It's the opposite. And you press. Now, people ask, how tight does it need to be? Well, you don't want to put it on so tight that you cause the gantry to move. I mean, you can get on here. So Ron is a big man. He can get up here and he can put a lot of force on that would cause the gantry to move, which if the gantry moves, you're going to have to reset the machine's home position. So put it on tight, but also tight enough that you can get it off, because when you're going to end up going in the opposite direction to loosen the nut. One thing to be careful of when you are releasing this nut, so I have it over here for a reason, because if you do this right here, your knee has a tendency to hit that E-stop. If you hit the E-stop, you've got to start over and set the home position. Experience. The one thing to be careful of from an experience perspective when you are loosening the nut, your hand, notice the height of my hand, and as I pull, I will run my hand into that corner or that yellow nut. Experience, it'll hurt, and it'll gouge some of your skin out. So exercise some care. This is the PVC board stuff that I was talking about that's called Sintra, that you use that O-bit for. But so make believe this is 4x8s, and we're going to set the home position right here at that corner, okay? So now that we have our bit installed, we're going to move the machine over. We're going to still leave it in fast mode to get it over close. And I'm going to put it in slow mode now so I can won't be so large movements. And I'm going to move over to this corner. Now, this is again a question of how precise do you have to be. If I'm cutting something out, I don't have to be that precise. I can get it just pretty close. And what you'll want to do is you'll want to visually, in setting the X, you'll want to look from this direction and make sure the center of the bit is close to X. I don't know, whoever's running the camera there, how am I doing? Is that close to be good for X? Probably close enough. And that's probably close enough for Y. And we don't have our automatic tool changer, sorry, our automatic Z set. So we're gonna manually just move this down to kind of touch the surface of the material. Okay, so we're going to call that the home position. Again, I'm not focused on precision here because we're going to cut something out. So again, this is documented in the wiki about how to navigate and do that.